Hello, this is your special education virtual content specialist here with the lesson for May 4. This lesson, as with all other lessons, can be found on TeachHub. This lesson, like other lessons, provides teachers with the title, the focus question, the learning objectives, including the standards and objectives for each lesson. We also provide guidance for using this resource, including instructional and technology guidance, implementation guidance for the lesson, guidance for summarizing, guidance for assessment during instruction, and general methods of engaging students with disabilities and multilingual learners. 8th graders are working on Unit 8, the Pythagorean Theorem, and irrational numbers. Day 6, Rational and Irrational Numbers, Part B. What is an irrational number? The introduction is an activity in which students investigate the value of the square root of 2. As a result, students should believe that the square root of 2 is about 1.5, maybe a little bit less. Students should also understand that the square root of 2 is a number that we can multiply by itself and get 2, so the following statement is true. Square root of 2 times square root of 2 is equal to 2. The goal of the introduction is to achieve a more precise value of the square root of 2 than about 1.5, maybe a little less. In other words, an exact solution to x squared equals 2 is required. In this activity, students are going to consider whether certain candidates are solutions to this equation. In order to support students, you can do the stronger and clearer each time protocol. So after students have had time to think about whether the numbers are solutions to the equation x squared equals 2, ask them to write a brief explanation. Invite students to meet with 2 to 3 other students for feedback. So if you're using breakout groups, this would be a great way of doing that. Display prompts for feedback that will help students strengthen their ideas and clarify their language. For example, what does it mean for a number to be a solution to an equation, and how do you know this number is or is not a solution to the equation? Students can borrow ideas and language from their partners to refine and clarify their original explanation. I modified the task from having all 4 numbers presented to just one at a time. That way students can choose an option, they can discuss with their peers and come back. First one is 1, and 1 is not a solution because 1 squared is 1 and not 2. 1/2 is not a solution because 1/2 squared is 1/4. 3/2 is not a solution because 3/2 squared is 9/4. And 7/5 is not a solution because 7/5 squared is 49/25. So on this slide, you can just read out the definition of a rational number. Wherever you have your vocabulary word wall, whether you're in person or remote, just make sure that you have a simplified definition for students to refer to for the unit. So now students are going to look at examples of rational numbers, and they're going to indicate the appropriate location for each of the rational numbers listed. So you can help students by divvying up the work. 7/4 is 1.75, which is approximately 3/4 of the way to 2. So you can say 7/4 would lie here on the number line, and 0 would be at 0. So 6/3 is 1/2, which would lie there. And 0.2 would lie there. For the independent practice, -1/3 would lie 1/3 of the way to -1. -5 easily is at -5. Square root of 9 is at 3. And negative square root of 16 over square root of 100 would be at 4/10, which would lie right here, because it would be -4/10. So -6 square root of 16 over square root of 100. After students are done putting the numbers on the number line, you can ask them, can you see why they are each a fraction or its opposite, to tie it in with the slide from before. Because fractions and ratios are closely related ideas, fractions and their opposites are called rational numbers. Emphasis on the ratio in rational. This part of the Explore has students writing down more numbers that are close to square root of 2 that are also rational. For this portion, you can use the Pear Deck number slide, so students have to enter a number. They should see when you show the responses that the number line is going to be close to 2 anytime they put an answer. And so you want to make sure that they have answers that are close to 2. And if they're not close to 2 on the number line that's being projected from Pear Deck, then you want to guide them to choosing something that is closer to that value. So some examples can be 10/7, because 10/7 squared is 149, 17/12, because 17/12 squared is 289 144, 13/9, because 13/9 squared is 169 81, or 141 hundredths, because 141 hundredths squared is 19,881 over 10,000, which are very close to square root of 2. Then you're going to ask them, can you find a value, aka a rational number, that is exactly square root of 2? And the answer is no. Now you're going to tell students what an irrational number is. It's a number that's not rational. More specifically, it's a number that's not a fraction or its opposite. You're going to read through the slide and just post this on a vocabulary word wall for your students. For this portion of the Explore, you're going through the question, is not finding something enough proof to say it doesn't exist? The first hypothetical situation, if I told you that there are no purple zebras and you spent your whole life traveling the world and never saw a purple zebra, does that mean I was right? You can set it up so that students just have to check yes or no, and then they have to explain why they chose that. Overall, students should be saying no. It is possible you just failed to find the purple zebra. And the second question is, so if we spent our whole lives testing different fractions and never quite got one whose square is 2, does that mean there are no such fractions? Again, you can set it up so students simply have to check yes or no and then explain their answer. And students should be saying, no, maybe you just haven't found it yet. So tell students that after you have them right, that we haven't learned enough to prove for sure that square root of 2 is not equivalent to a fraction. For now, we just have to trust that there are numbers on the number line that are not equivalent to a fraction, and that square root of 2 is one of them. However, it is possible to get very close estimates with fractions. Then you're going to explain that square root of 2 isn't a rational number, and you're just repeating that explanation from the slide beforehand. Also know, to support students, I switched the order of the slides. So I switched H to go in front of slide F and G. That way students can understand this conjecture from slide F and G. For the summary, students are responding to the question, what is an irrational number? Give them a sentence starter. Then they can complete the cool down. There is a lesson support video, so point that out to students, especially those who were struggling throughout the lesson. Here are some additional practice that students can complete, including IXL 8th grade D.5, identify rational and irrational numbers, Khan Academy, classified numbers, rational and irrational, and the open up practice problems. Here are the resource citations, so refer to them if you would like further support for your students. If you have any questions, please reach out to your virtual content specialist. Thank you.